This is the second part of task 6.8. Previously we talked about similarity, right triangles, and this is going to be your introduction to trigonometry. You guys can take your notes on this page of the task. Just cross out 5 and 6, and you could use the space down below for your notes. Okay, to recap, previously we drew a right triangle with 60 degrees. We called that 60 degrees our reference angle. And I like to draw a person right there at our reference angle. And that just helps me figure out how to label the sides. Okay, so reference angle. Now, from your point of view, how would we name the sides? We give them 3 names. Now, one side always stays the same, the hypotenuse. That never changes name. It's always the side across from the right angle. Now, from your point of view, this leg is next to you, so we call that the adjacent leg. From your point of view, this leg is away from you, and so we call that the opposite leg. Same thing over here. Now, both these triangles were similar because they have a right angle and another pair of angles that are congruent, so they were similar by a similarity theorem. Then we also, after measuring those and studying stuff, we saw that the ratio of pairs of sides would have the following ratios. So opposite and hypotenuse had a ratio of this for both triangles. Adjacent and hypotenuse had a ratio of 0.5. And opposite and adjacent legs, opposite over adjacent, gave us a ratio of 1.73. And hopefully that makes sense. The opposite leg is much longer than the adjacent leg, so I should have a fraction bigger than 1. Now, this relationship, we can draw more triangles and whatnot, but there's got to be a faster way to figure out these ratios that are important for us to solve for parts of right triangles. So we give special names for that. When we compare the opposite over hypotenuse, we call that sine. Sine is opposite over hypotenuse. When we take adjacent over hypotenuse, we call that cosine. And then when we have opposite over adjacent, we call that tangent. Okay, so sine, cosine, and tangent. Now your calculator is going to help you figure this out. So these ratios are related to when we have 60 degrees as a reference angle. So in our calculator, if you have this calculator, great, and I'll show you guys how to use your personal calculator if you got something different. But here, just so you guys can show this, I could have saved myself a lot of work if I just used my calculator. I'm going to type in sine of 60 degrees. And there's that ratio of 0.866. So sine, which is the ratio of opposite over hypotenuse, when we have a 60 degree angle, gives us that ratio. Okay, I'm going to repeat with cosine. Cosine of 60 degrees gives us 0.5. Boom. So when I compare adjacent and hypotenuse, whenever I use 60 degrees as my reference angle, I will get 0.5 as the ratio of the two sides. Tangent. Type in tangent, 60 degrees, 1.732. Once again, for any right triangle where one of the angles is 60 degrees, and that's my reference angle, the ratio of opposite over adjacent will be 1.732. Okay? Now that works for 60. But this also works for any kind of triangle. Okay? Let me go with messier angles. Okay, suppose I've got 2 triangles here. These 2 triangles are similar by the AA similarity theorem, and I could figure out the ratios of opposite over hypotenuse, adjacent hypotenuse, and opposite over adjacent. But why work that hard? I will use trig to help us find those answers quickly, those ratios. Okay, so I've labeled the acute angle 26.6, so I will draw my person right there. And that hopefully should make sense that from the person's point of view, the leg next to the person is adjacent, the leg away from them is opposite, and the longer side is the hypotenuse, which is definitely not a leg. Okay, same thing here. Okay, so we got 2 similar triangles, and I've labeled the sides based on the person standing at the corner at the reference angle. Okay, so opposite over hypotenuse we know is sine. Okay, and I'm going to put opposite over hypotenuse equals sine. And I'm going to type in 26.6. And so sine of 26.6 degrees gives me a ratio of about 0.448. Okay? If I were to actually measure the sides, that would be the ratio that I got. But why work that hard? Sine is the ratio of opposite over hypotenuse. Given that angle, There's my ratio. Okay, let's repeat. Adjacent over hypotenuse is cosine. So I'm going to write cosine of 26.6 degrees. Type that into my calculator. So cosine of 26.6. And we get a ratio of about 0.894. Okay, and then lastly, opposite over adjacent. That is tangent. So that's equal to tangent of 26.6 degrees. And type that in my calculator, 26.6 degrees. And we get a ratio of about 0.501. Okay, so the convenience of knowing what these ratios are, knowing that angle, the relationship, will give us that ratio of comparing sides. We're going to study more of this over the next couple weeks, and you'll have a very deep understanding of that. Until then, later.